Hello guys, I'm Miles with best.edu, and today we have McGraw-Hill 6-1 perpendicular bisectors and circumcenter. So on this first one, question 1, it's find FM. So because the hypotenuse of G, K, and F is 2.8 and GK equals KM, and there is a right angle. Because of the right angle and those being equal, the top of it, hypotenuse of FKM equals 2.8. So, XW on this one is just like the last problem. So, XY equals 7.5. And because YZ and ZW equals 5, and there's a right angle, it makes it 7.5. So, I'm going to put that in real quick because I didn't do that. Hold on. Just to make sure it's right. It is, of course. There's the question. All right, so we're on question 3. All right, so you've got both the hypotenuses are equal, and you have a right angle with the bisector here, right? So you've got this line, which cuts it in half, which makes both of these equal because both of the hypotenuses are equal. And we're looking for x. So x equals, we're going to find that. So 5x minus 6 equals 3x plus 8, right? So you want to take the 3x, you want to move it to the other side, subtract it from 5. That gives you 2x minus 6 equals 8. Plus 6 plus 6, boom, boom. You got 2x equals 14, so I'm a little slow today, over 2x. This is 6. That's not right. No, it's 7. I apologize. We put this on here. I might have to edit that out. Sorry, my sister's watching me, so it's a little confusing. And there you go. So this one's incredibly similar to the other one. We're looking for x. This is number 4, by the way. So we've got 2x. Hold on, let me read. 2x plus 25 equals 5x minus 30. Also, for the last question and this one, I would like to clarify that the reason we're doing this is because both sides are equal, right? Because of the hypotenuse being equal and the right angle. So we're going to do 30 on both sides, plus 30, which gets you 54. And that'll be 2x plus 54 equals 5x minus 2x. Both sides, you got 54 equals 3x. And 54 divided by 3 equals 18. So your final answer for that is x equals 18. So this is question 5. Here we have 2 equal hypotenuses, right? And we know this entire side is 12, okay? And we have a right angle here. Because of this right angle and equal hypotenuse, we know both of these are equal. JK and KL are equal. We're solving for KL, and because this is half of 12, it equals 6. So 5 equals 6. All right. Question 6. So in this problem, we have to find BR, okay? Right? So D is the circumcenter. Well, let me erase that. I'll explain that later. D is the circumcenter of ABC. So this is the middle, and that means AD, BD, and CD are all equal because that's the circumcenter. I can go into more depth about that in another video. So we know CD equals 11.1 and RD equals 5.2, and we have to round our answer to the nearest tenth. So what we're looking for is, drop the top of my Sharpie. Okay, highlighter, same thing. No, it's not a highlighter, it's a Dry erase marker is what it is. So, because all three of these are equal, that means this is 11.1 because D is the circumcenter, making all three of these equal. An intercenter, just going to explain this for later, would be SD, RD, and QD. And the reason that it's not in this problem. It's not in this problem. There's not an intercenter in this problem. Okay? But because those are equal, because that would be the intercenter. I'll explain later. Okay? So, what we're looking for now is because we're looking for BR, we have DR and DB, we don't have BR. Okay? So the way to get BR is we have to use the Pythagorean theorem. Alright? And to understand the Pythagorean theorem, we have to understand that A squared is referencing the side as well as B squared is referencing the side. So these two here. No, sorry, I'm completely wrong. Both still sides, these two here, okay? Now, C squared is the hypotenuse. So you see here, should have used this to be a better example. This hypotenuse, this is the part that is at a slant and cannot have a right angle, okay? So, we need to use this to figure out BR, right? So, we're going to put 5.2 squared plus B squared. The reason we're putting B squared is because we don't know BR. All right, BR is what we're looking for, okay? Equals C squared. No, we put 11.1 squared, okay? So, we need to square each of them. We need to simplify, okay? So we've got 27.04 for 5.2 squared plus B squared equals 123.21. I would suggest following along on your own calculator. It's a good way to learn. Okay, so you want to take 27.04 minus, and we want to move 27.04 to the opposite side, which is going to be 27.04. All right, and that was not the answer, by the way, but hold on. So when you do that, we get B squared equals 96. So now that we're here, we need to square root B squared and 96. It was 96. I'm messing up a lot today, okay? And that means B equals 9.8. So, sorry, BR equals 9.8. But because we are calculating this side, which was BR is 9.8. And I already have that checked for you, so I don't have to re-record this video. But there's everything you need to know. All right, question 7. So for this one, we're solving for FL. To get FL, we need to understand that this height is the same for both sides. And because this is the circumcenter, we also understand that both of these, LE and LF, are both equal. Okay? So we're solving for FL. So to do that, we need to do what we did on the last one, very similar to the last one. This one just took me forever to do because I made a stupid mistake on it, and my siblings were interrupting me, so that's why I've completely lost my track. So, we're going to start off by trying to Pythagorean theorem, going 2.74 squared, okay? So, 2.74 squared is this, but we need to understand we're solving for LE first, and that, which also solving for LE equals LF, FL, same thing, okay? So, plus B squared, I'm just going to erase this because I already explained that, equals 5.06 squared, all right? So, we've got this. Now we need to square both 2.74 and square 5.06, which gives us 7.5076 plus B squared equals to 5.6037. Okay. There you go. So that's it squared. Okay. So now from here we need to simplify. Going 7.5076 minus 7.5076. So we take 7.5076 minus 25.6037. Okay. That gives us B b squared equals 18.096. Okay? Then we need to square root it. Boom, boom. B. Whoa. So at this point, we get FL. Okay? But LE, FL, it can go either way. But we were solving for B. You know, it automatically translates to FL. So we go FL equals 4.25. I have that verified down here. So we've got 4.25. There's your answer. And that's how we did it. There we go. All right, so we've got question 8. And the question is, determine whether there's enough information given in the diagram to find the value of x. If there is, find the value of x. If not, explain what needs to be given. So the reason that this is A, which is no, we need to know the segment bisector is a perpendicular bisector. So we have two equal lengths, right? We have two equal lengths, all right? That's all good and dandy, right? But you have this line that goes up and down, right? And you have your triangle, which can be anywhere along this line, the top of it can be, okay? Go ahead, Enzo, you can move that. Here, come over here. Thank you. All right, so for this to be possible, it would have to have a right angle. Now, because you can't trust math face on, you have to understand that it could look like this. All right, so this one's an altered version of the last one we just did, right? So we have, the question is, determine whether there's enough information given in the diagram to find the value of x. If there is, find the value of x. If not, explain what needs to be given, okay? So I choose A once again, which was no, which reads, we need to know whether the hypotenuse of the triangles are congruent, right? And here's why we need to know that, right? So we have this. Remember, it was both of those sides were equal in the last one, okay? But in this one, it's not. We only have a right angle. And here's what would happen if x could be any number, right? Go ahead, thank you, Enzo. Right? It could look like this, where one side is way longer than the other one because both of these sides are not equal. There's your answer. I'm going to be a lot more vague on and probably not explain as well because it took me way too long to figure out, but I'm going to try and explain it. So I'm going to read you the question. Use the figure to complete the paragraph proof of the perpendicular bisector theorem, theorem 6.1. Okay, so it is given that CD is the perpendicular bisector of AB. So we have CD is the perpendicular bisector of AB. All right, so we have to prove that C is equal distance from AB. All right, pretty simple. So the first one is CD is the perpendicular bisector of AB, right? So we've got CD, AB, perpendicular bisector, okay? So we got, calm down. CD is perpendicular bisector of AB. Because that was given, we know that there's a right angle here. I mean, that goes all the way around, right? But we know that's a perpendicular bisector, meaning it goes perpendicular and bisects A and B. So bisect means divided equally. So we know that both those sides are equal, okay? E is the midpoint. That also tells us, because we knew what we did before, that makes E the midpoint. Thus, AE is equal to BE. So we have AE equals BE. Simple as that. We know that that is the midpoint, which makes them both equal, right? All right, because the 2 points determine a line, you can draw segments from AC and AB to C, right? So it's talking about this right here. Okay. And they are, that didn't really matter, but that is right angles, and we already established that, okay? By the definition of perpendicular, because all right angles are congruent. That was a completely different sentence. Because all right angles are congruent, CE CEA, and CEB are right angles, which we established already. Thus, CEA, which makes this our triangle, okay? And triangle CEB are both equal by SAS, which is side, angle, side. So that's where we've got two sides, which would be these two sides, and an angle here, which we know is a right angle. Okay? I'm going to erase that because we got it. All right. CA equals CB, we know that, by the definition of equidistant. All right? C is equidistance from AB. That is how we figured it out through all of that. And I just realized as I was explaining this, you could probably see as I was explaining it, that it's so much easier if you wrote it down. And that took me forever because I did not write it down. And that would have been so much easier. So the blanks for each of them are perpendicular bisector, midpoint, right angles, reflexive, and equidistant, which should be on your screen about now. So this question is question 11. It's going to be incredibly hard to put on the board, right? Because it doesn't really make much sense, and it's very confusing to draw. But I'm going to read it to you and give you the answer. So, consider CD. Describe the set of all points in a space that are equidistant from C and D, okay? So I put A for this one, which is a plane perpendicular to a plane in which CD lies and bisecting CD. So it's bisecting it, so that makes, boom, two equal sides. And it's perpendicular to it. It doesn't really make much sense, okay? But the answer is A, is what it is. And I'm going to read it again. A plane perpendicular to the plane in which CD lies, bisecting CD. So this would be a plane that cuts it in half, sort of. See, it's very hard to put on a board, but there you go. All right, so question 12. Proof is use the figure to complete the two-column proof of the converse of the perpendicular bisector, theorem 6.2. So the given is CA is equal to CB, and AD equals BD, okay? And we have to prove C and D are on the perpendicular bisector, okay? So. C and D equal C and D, right? Line CD equals line CD. And I meant, when I was saying the given, I meant to say line, but I forgot to. Anyway, so you've got CD equals CD. That's talking about this line, but that also is talking in relation to both sides of the shape, okay?
Hi, my name is Stella. I'm going to take Miles' job for this last time. So this is ACD. This is angle BCD. We know that AC is equal to CB. That means we use angle, side. Emmett side. And that was teaching with Stella.
This one is part 4 on question 12, right? So, for this one, it is ACD equals BCD. ACD equals BCD, okay? Now, for the reason is corresponding parts of congruent triangles are congruent. So that is CPCTC. That's what that stands for. So what that is saying is that D on this one equals D, C on this one equals C, A equals B is what it's saying, because they're corresponding is what it is. So CE equals CE on both of the triangles, and that is the reflexive property of congruence is YCE equals CE. All right, number 7 on question 12 is CPCTC, which is corresponding parts of congruent triangles are congruent, okay? And the reason it's like that is because the bottoms of these two angles, A and B, are equal, and E is equal to E, which makes it so both AE and BE are equal because they are congruent, if I'm using the right terminology.
Yeah, they're congruent.
All right, for number 6 on question 12, which I don't know why there's a question this long. So this one is triangle CEA equals triangle CEB. You have triangle CEA and triangle CEB. Okay? And that one is side angle side for its reason, because you have a side, an angle, and a side, which both applies to both of the sides. And that's because you're able to tell. This one's pretty self-explanatory. Number 10, CEA equals CEB, which the linear pairs, that's pretty self-explanatory. On question 12, number 11 is supplementary angles. Okay, so CEA and CEB are supplementary, and that'd be the supplementary angles theorem, right? So no matter what these two angles are, I use 90 and 90, for example, right? So with these two, they both equal 180 in the end, okay? And that is what makes it a supplementary angle. Two angles that equal 180, and that is what that is, because it is split by an angle bisector. 12 on question 12 is angle CEA plus angle CEB equals 180, which this is the definition of supplementary angles. So no matter what, you got this and this, okay? You got this, you got this and this. Both of these angles are going to add up to 180 no matter what, and that's what's happening with these two, which makes it 180, right? Number 13 on question 12 is CEA plus CEA equals 180, which is substitution, right? That means that both of these angles are 90 degrees, which makes them both add up to 180, right? But if you just have CEA plus CEA, you still get 180. 14 on question 12 is exactly the same, where it is saying CEA times 2 equals 180, because we know that that is 90 degrees, which is the exact same as the last one. All right, so number 15 on question 12 is CEA equals 90 degrees, which is the division property of equality, which is what we've been talking about for the past 3 parts of this question. You can tell I'm getting tired of this. So because we have confirmed that this one is 90 degrees and this one is 90 degrees, we know it is the definition of right angle, because it literally could not be anything else. Number 17 on question 12, CD is perpendicular to AB. It is, because we know 90 degrees, this is this, 90 degrees, 90 degrees, 90 degrees. We know this is all right angles, okay? And that'd be the definition of perpendicular lines. That's what it is, this perpendicular right there. There you go. Question 12 is exactly the same, being, question 12, part 18, which is CD is the perpendicular bisector of AD, CD, perpendicular bisector of AB, and that's the definition of a perpendicular bisector, which is exactly what we just went over in the last one. So now we're finally on this last one, which has no answer, because it's already done for us. I'm going to go ahead and submit it. Go ahead and submit this. This is taking me forever to do, but I've learned a lot, and I hope you guys have too. Go ahead, assignment submitted. Done. Whew. Thank you for watching. I've gotten a lot done today. Not really. I've explained a lot today, and I hope that you guys have learned as well, and I hope that this is helpful. Please subscribe to best.edu and have a wonderful day, a wonderful week.